So today we are discussing that performance of IC engine, performance parameter of IC engine. First performance parameter that was discussed was your power, and today we will discuss your thermal efficiency. So basically we know that what do we mean by efficiency? Efficiency is known as your output by input. So in the thermal efficiency, what is thermal efficiency? It is defined as the ratio of net work done by heat supply. So in case of your IC engine, so what is your output? Output is your power. It may be indicator power, it may be your brake power. And what is your input? Input is your fuel supply. It is your fuel supply. So likewise we are calculating your thermal efficiency. So first we will discuss brake thermal efficiency. So what is brake thermal efficiency? As I told you that efficiency is your output by input, but in case of your IC engine, what is your output? Output is your power. So we are calculating your brake thermal efficiency. So your output is your brake power, and what is your input? Input is your fuel supply. So brake thermal efficiency is defined as the ratio of brake power to the energy supply rate, or you can say fuel supply. So mathematically we can denote this on eta BTS, that efficiency of brake thermal efficiency. That is your brake power, that's your output by what is the supply? Fuel supply. Fuel supply means mass flow rate of fuel into its calorific value. So when you are going to calculating the mass flow rate of fuel, it must be in kilojoule per second, sorry, kg per second, and your calorific value, that is your kilojoule per kg. Then we will discuss indicated thermal efficiency. So the name is said that indicated thermal efficiency, that means your output is your indicated power and your input is your energy fuel supply per second. Energy of fuel per second. So that is your energy of fuel supply per second, that is your mass flow rate of fuel into its calorific value. So from that, we mathematically will denote indicated power by mass flow rate of fuel into its calorific value. That will be give us indicated power. So likewise, we are calculating mechanical efficiency. What is your mechanical efficiency? It is the ratio of brake power to indicated power. So as I know that indicated power is your gross power. From that, some of the power will be lost due to friction and we get brake power. So if the two power is given in a question, then how you can define that which one is your indicated power and which one is your brake power? The smallest number of power, that is known as your brake power, and indicator power would be more. So you can say that brake power is less than that of your indicated power. So indicated power by brake power, brake power by indicated power, that will be give us mechanical efficiency. Then we will go for relative efficiency. What is your relative efficiency? It is defined as the ratio of actual thermal efficiency to air standard efficiency. So what is your actual power? Your brake power, that is useful. So brake thermal efficiency by air standard efficiency, that will be give us relative efficiency. So what is the relative efficiency of the engine? It will be varies from 75% to 95%. Then brake thermal efficiency, that formula that you know, that is your brake power by mass flow rate of fuel into calorific fuel. From that you can calculate. Then how to calculate air standard efficiency? So there are two type of engine, a petrol engine and diesel engine. Petrol engine works on Otto cycle. The efficiency of Otto cycle is your air standard efficiency of petrol engine. That is your 1 minus 1 by R to the power gamma. What is R? R is your compression ratio. Gamma is your adiabatic index, that is gamma for air is 1.4. Then for diesel engine, the diesel engine works on diesel cycle. So if you calculate the air standard efficiency, the air standard efficiency of diesel engine is diesel cycle. So basically the efficiency of diesel cycle is 1 minus 1 by R to the power gamma minus 1 into rho to the power gamma minus 1 divided by gamma into rho minus 1. What is that rho? Rho is your cutoff ratio and R is your compression ratio, gamma that is your adiabatic index, that is 1.4 for air that you can take. From that you can calculate the relative efficiency. Then we will go for volumetric efficiency. So what is volumetric efficiency? The actual volume of charge inducted into the cylinder during suction stroke divided by the swept to the swept volume. So that volume, swept volume is when piston travel from TDC to PDC, that volume is known as your swept volume. So according to that swept volume, actually how much air fuel mixture or air will be enter into the cylinder, that we calculate is your volumetric efficiency. So volumetric efficiency for normal engine will be lies between 70 to 80%. Clear? Then how to calculate? The volumetric efficiency is equal to actual volume of flow rate of air into the engine cylinder divided by the volume displaced into number of working stroke per second into number of cylinders. So what is your actual volume flow rate? That is your mass flow rate of air by density volume. We know that density is equal to mass by volume. So that what is volume? Volume is equal to mass by density. So that is the mass flow rate of air divided by density of air into volume displaced. How much volume will be displaced? Swept volume pi by 4 d square N into number of working stroke per second into number of cylinder. So this way we can calculate your volumetric. Then the third parameter is your specific fuel consumption. So what is specific fuel consumption? It is the amount of fuel consumed to produce unit power output, that is known as your specific fuel consumption. Or you can say it is defined as the ratio of fuel consumption per hour to the unit power output. What is the fuel consumption per hour? Fuel consumption means what? Mass of fuel per hour. So mass of fuel unit is kg per hour, means that is kg per hour divided by power output is your kilowatt. So unit is your kg per kilowatt hour. So depending upon the power, the specific fuel consumption may be brake specific fuel consumption and indicated specific fuel consumption. So now we will discuss what is brake specific fuel consumption, that is BSFC. It will be noted as BSFC. So what is brake specific fuel consumption? It is the amount of fuel consumed to produce unit of brake power in hour. Per hour is known as your brake specific fuel consumption. So, brake specific fuel consumption BSFC is equal to mass flow rate of fuel in kg per hour divided by brake power. M dot F means mass flow rate of fuel. That means some time will be divided here. Mass flow rate of fuel into its brake power. That will be give us brake specific fuel consumption. Unit is your kg per kilowatt hour. And this parameter will be decide. What it will be decide? It will decide the economical power production from an engine. Then is here, if you will calculate the indicated specific fuel consumption, it will be a mass flow rate of fuel by indicated power, that is m dot F by IP. Then we will discuss here how we will define air fuel ratio. Fuel air ratio, that is F by A, it is the ratio of mass of fuel to mass of air. So it is expressed by A by F, mass of air divided mass flow rate of air by mass flow rate of fuel. So what is the stoichiometric air fuel ratio? That is 15:1. So 17:1 to 19:1, that is your 15% of air and 1% of what? 1% of fuel. So if the air percentage will be increases 17% to 19%, so that mixture is known as your lean mixture. And if the air percentage will be decreases from 12.1 to 10.1, that is known as your rich mixture. That means in this mixture, the air percentage is less than that of your stoichiometry. Here the air percentage is more. So basically the air fuel ratio range from how much? 12 to 19 for petrol engine and 20 to 60 for what? Diesel engine. Next we will discuss calorific value. So what is calorific value? Calorific value is defined as that amount of thermal energy released by burning 1 kg of fuel. After the complete combustion of fuel, the thermal energy released is known as your what? That is known as your calorific value. In the course of third semester, we will discuss that HCV, higher calorific value and lower calorific value. If it will be cooled down to the initial temperature, that is known as your what? That is known as your higher calorific value. If that will be the product of combustion will be exhausted with the it will be exhausted. So that is known as your what? Lower calorific. So then we will discuss your mean speed of the piston. What is your mean speed of the piston? That is will be defined as 2 into L into M. That is 2 into length of stroke into revolution per second. That is your RPM, speed of the engine. That will be defined as it will be 8 to 15 meter per second for what?